Hello everyone, welcome to the first part of the RTS tutorial series. On this part, we'll be focusing more on the top-down RTS camera controller. As you can see on the scene, I've set up a basic ground plane and some few cubes just to test out if the camera is moving at all. So without further ado, let's head to the tutorial. First, I'm going to create a new C# script and call it camera controller. Then I'll open it up with MonoDevelop. Notice that I'm using an older version of Unity. The specific version is 4.6, just for comfortability and personal interest. So in MonoDevelop, we'll delete the start method since we're not going to use it at all. And in here, we'll create two variables. First one is a vector 3 for the limit, and the second one is the minimum and maximum zoom. Notice that I've used a comma here. This is a technique to make your codes much more shorter, and you can use it with variables that has the same data type. So save that up and let's head back to Unity again. In Unity, select the main camera and drag the camera controller here. Notice that the limit is accepting 3 axes, X, Y, and Z, but we're only using the X and the Z axis. So let's head back to MonoDevelop and change the vector 3 to vector 2 only. Let's head back to Unity again, and there, we only have 2 axes, but it's a y-axis. What we can do here is map the value of the y-axis into the z-axis later. We'll have a talk about that later. So let's head back to MonoDevelop again and start doing the codes. So all the codes will be placed inside the update method. First of all, we're going to create a variable for the position of our camera. That will be vector3 pos equals transform.position. The pos variable is taking the position of the camera. Next, to make it shorter, we'll just add up each axis with the value of the keys that we're pressing. So for the x-axis, we'll be using pos.x plus equals input.getAxis horizontal. So why are we using horizontal instead of mapping it with the keys? We're using horizontal so we can use either the A and D key on the keyboard or the right and left arrow keys. So the value of horizontal axis is either 1 or -1, or adding it up to the x axis of the pos. The next one will be mapping the z axis, so that will be pos.z plus equals input.getAxis vertical. Now it's just the same as the pos x or the horizontal, but we're using the vertical, which is the up and down arrow key or the W and S key. Now to make it move on the game, we'll need to set up the transform.position until the position is equals to pos. Save that up, head back to Unity. Let's test it, and you can see it's moving by just tapping A and D, W, S, or by using the arrow keys, left, right, up, and down. Cool, but it's too fast and we need it to be slower. So let's head back to MonoDevelop and just add up on this line 0.3f. Same on the vertical. Let's head back to Unity, and there, it's much better. But since we're still not implementing the limits, we can move beyond the borders. So to do this, let's head back to MonoDevelop above the transform, and let's create a clamp for it. So to do this, we'll just do this basic code. Pos.x is equals to matf.clamp, and then clamp has 3 variables: the value, the minimum, and the maximum. So the value would be pos.x, and the minimum will be negative limit. The maximum would be limit. Let's just copy this for the pos.z. There. Forgot to add the x, and this we'll just put it as the y. Sorry about that. So in Unity, we'll set the limit to 10 and the y to 10. So whenever you try to get over it, it will stop us. Cool. The next one, we'll create the zoom function. Now there's 2 types of zoom function. Either we can use the field of view to zoom in and zoom out, or we can use the y-axis to zoom in and zoom out. So let's get back to the MonoDevelop, and we'll create another variable here. Let's call it float and then scroll. And the value of it would be the axis of the mouse wheel. Now to implement this in our script, we'll just add up here another statement. So this scrolling is for the y-axis scrolling. So that would be pos the y plus equals negative scroll times 5f. Let's head back to Unity and test it out. There, it's working. So why did I use negative scroll here? That's because the mouse wheel is inverted. So when you scroll up, it's actually adding up. And when you scroll down, it's going to the negative side. Let me show you that. See, I'm actually scrolling down, but it's zooming in. And when I'm scrolling up, it's zooming out. And let's revert that back up to negative scroll. Save it. Now to create a clamp for this, for the limit, we'll just do it like the pos.x clamp. So that would be pos.y equals to matf.clamp, and then the value for it would be pos.y. On the minimum and the maximum value, we'll just put minimum zoom and maximum zoom. Let's save that up, set back to Unity, and let's add a minimum and maximum zoom. So my minimum zoom would be 2 and my maximum zoom would be 7. Let's test it, and when I zoom out, it's not going further and away. When I zoom in, it's not going in more further. Awesome. The next, we'll program the perspective zooming. So let's head back to model develop. Let's comment this out and add it here instead. So that would be camera.main.field of view minus equals scroll times 20. Save that up. Let's head back to Unity and let's test it. So you can see I'm zooming in and out just like the y-axis zooming. Let's add a clamp for it. Camera.main equals matf.clamp. So the value would be camera.main.field of view. The minimum value would be min zoom and the maximum value would be max zoom. Let's change this to 20 and the maximum to 60. So when I zoom in, it's only on the 20th. And when I zoom out, it's not gonna zoom out anymore. Cool. So that ends up our first part of the RTS tutorial series. I'll leave the link to the script download on the description box. Thank you for watching and I'll see you on the next part. Bye.